Good morning, Kasturians. So today let us start with the chapter Work, Power and Energy. And in this chapter today particularly what we will be discussing today is work energy theorem. Okay, so let us start. So first of all let us see what does this work energy theorem states. Work energy theorem states that uh, work done by the force in displacing any object or any body, it is always equals to change in its kinetic energy. Okay, so how we can write it as we can write it as work done is equals to change in kinetic energy. Okay, if the object has moved from this initial position, let us consider at this initial position kinetic energy was ki, that means kinetic energy initial, I represents the initial, and the object has moved to a final position. Okay, this is the final position, this is the initial position, and at the final position kinetic energy of the particle is kf. Okay, so what does this theorem say? It says that work done in displacing the object, or work done uh, by the force in displacing the object is always equals to the difference in their kinetic energies. So work done is equals to difference in their kinetic energies, means k final minus k initial. Okay, so this is the statement of work energy theorem. To prove this statement, let us consider that m is mass of the body. Okay, u is its initial position, v is its final velocity, u is its initial velocity, v final velocity, a is acceleration of the particle, and f is force experienced, or you can say the force applied on the object. Okay, now let us see. Let us start from the, as we already know what is work. Okay, work done we have already studied. So from the work done by the body in a small displacement. Okay, work done along a small displacement by the body when some force is acting on it is work done is defined as force into perpendicular distance, or force into its displacement. Okay, so can we can, so what we have done here is the force, we can write force as force is equals to mass into acceleration, and to acceleration we can write as m into acceleration is change in velocity with respect to time, so that is dv upon dt. Okay, so this is the value of force that is substituted here. So now what do we get? Work dw is equals to m dv upon dt into ds. Now see, if we put this dv outside and take this dt along with this ds, what do we get? Rate of change of distance with respect to time is velocity. Okay, so this is what we have done here, ds upon dt and dv outside. So ds upon dt is velocity, rate of change of distance is velocity. So the equation becomes dw is equals to mv into dv. Now this is the small work done. Okay, work done through a small displacement, work done in a small displacement. Now we want to find out the total work done. So what we can do to find out total work done, we already know, simply we integrate the equation. So if we want to find out total work done, we will simple integrate this equation, and this integration of this equation for v will be from 0 to v. Okay, so what do we get here? We will be simply getting the total work done, that is w, and on the right hand side what we will be getting, dekho, m is a constant value, so m will come outside, so the integration will be with respect to v, so inside we are having v dv. Okay, so the power of v is 1, and we already know how we integrate an equation. If we are having x to the power n, we want to integrate this with respect to dx. So what will be the integration? It will be x to the power n plus 1 upon n plus 1. Okay, so this is what done here. Here we are integrating with respect to v. So if the in place of x, we will simple substitute. Here v is the variable. Okay, here x is the variable. I believe you are understanding this. So here v power is 1, so 1 plus 1 upon 1 plus 1, so m v to the power 2 upon 2, and the integration is from देखो यहाँ पे we have considered the integration from u to v. U is the initial velocity and v is the final velocity. Okay, the integration of velocity is from initial velocity to final velocity. Okay, so now if we take 1 half and m outside as they are constant, and we put the value of v and u. Okay, if we open this bracket, so what do we get? First we will put v in place of this v, and then with the negative sign u in place of this v, so v square minus u square. So if we open this bracket, so what do we get? 1 upon 2 m v square minus half m u square. Okay, so this is what we will get after we open this bracket. So this is, we already know, this is final velocity of the particle. So this equation is final kinetic energy of the particle, and this u is initial velocity of the particle. So This is initial kinetic energy of the particle. Okay, so this is kf minus ki. What is this? This is increase in the kinetic energy, or you can say the change in kinetic energy of the body. Okay, so this was actually the statement of work energy theorem. Hence this proves work energy theorem. Okay, so that's all for today. Other we will be discussing in the other class. Okay, so thanks.